If you're building modern AI applications, it feels like the platforms are they're evolving at a breakneck pace.
Oh, absolutely. It's a constant race.
And I think the biggest challenge isn't really the technology itself, is it?
Yeah.
It's finding that architectural blueprint,
Yes.
knowing which service to use and when, and maybe more importantly, knowing those specific security gotchas or operational details that'll save you a week of painful debugging.
Exactly. We've been handed this comprehensive stack of sources covering the entire Microsoft Azure AI ecosystem. We're talking everything from foundational services like Foundry right through to the tiny nuances of vision and language.
What's our mission here?
Pure distillation.
Yeah.
We're going to cut through all the dense documentation to deliver that critical what to use when knowledge and the specific design choices that really transform a prototype into a production-ready system. This is your shortcut to architectural insight.
Okay, let's unpack this. Let's start right at the foundation.
Yeah.
Because before you even think about a model, you need the operating system. So if a listener needs to develop a custom AI model, maybe train it with their own proprietary data, and then manage that whole life cycle, what's a central platform for that?
That is Azure AI Foundry, period. You should think of it as the central hub or like a specialized AI operating system that's recommended for model development.
Right.
It gives you all the tooling you need for integrating your data, deploying custom models, and managing the entire suite of AI resources securely. It's the choice that signals you're moving beyond just simple API calls into real custom AI.
That makes a lot of sense. It brings it all under one roof. But as soon as you say proprietary data, we have to talk security.
Immediately.
So how do large enterprises manage access control to these services? What are the supported authentication methods?
Okay, so there are really two enterprise-grade ways to do it. You can use the traditional method, a subscription key. It's quick, but, less secure.
The quick and dirty way.
Exactly. And then you have the preferred enterprise method, which is using Microsoft Entra ID. And that's usually leveraging a service principal and RBAC, role-based access control.
And just as important, what's not on that list? Because that's often where the friction happens in a big company.
This is a big one. You need to be specific. You cannot use SML tokens or Kerberos to authenticate to the core Azure AI services.
Why?
So if your architecture relies heavily on those for other systems, you have to adjust your strategy for AI.
That's a sharp distinction that could absolutely halt a deployment.
Yeah.
So let's talk network. If I enable strict firewall rules on my AI services account and I have an app sitting out on the public internet, how does that app get in?
Right. With those rules on, you've got two pathways. The most secure path is granting access through a specific virtual network. But if your application has to live on the internet, you have to add that internet IP range or the app's specific outbound IP to the firewall rules. You're explicitly punching a hole for it.
Speaking of headaches, and I think every developer has spent a miserable hour at 3 a.m. on this one, the sources highlight this dreaded mismatch status when you're dealing with containerized apps.
Yes.
What does that immediately tell us?
It's the classic frustrating mistake that thankfully has a quick fix. If you see mismatch, it almost always means the wrong API key was used for the resource type.
So you're using a vision key for a language resource or something.
Exactly. The key takeaway is, if it says mismatch, stop checking your network. Just confirm the key matches the service.
That tip alone is gold. Okay, let's wrap up governance for this section. If we're running Foundry and we need diagnostic logging for audits, performance, compliance, what are the two prerequisites?
You need two distinct resources. They serve different goals. First, you need an Azure storage account. That's for long-term log retention, audit trails, backups.
Okay, the raw data.
Right. And second, you must have a log analytics workspace. That workspace gives you the search and analysis tools to actually make sense of those raw logs.
So, storage for the files, log analytics for the insights, solid.
Yep.
Now that we've locked down the platform, let's pivot to the data, specifically documents for automated document processing. I'm thinking invoices, receipts, that kind of thing. What service minimizes the effort by giving us pre-built intelligence?
That's Azure AI Document Intelligence, or AID. It is absolutely the go-to because it specializes in taking scanned documents and just pulling out text and key value pairs using its pre-trained models.
And which pre-built models handle the biggest headaches for businesses right out of the box?
The ones that handle finance documents, invoice, receipt, and W-2. It's a huge time saver.
Right.
But and this is the key distinction, if you need to process custom things like internal timesheets or meeting minutes.
Your own company's format.
Right, those are not pre-built. You have to add those as custom models.
That contrast is critical. And if I'm just using the basic pre-built read model, which files will it accept? I'm more interested in what it will reject.
It supports PDF, Word, and Excel. The important exclusions are TXT, JSON, and XML files. Those formats are explicitly unsupported by that specific model.
Very specific, but necessary to know. Now let's say we're dealing with sensitive contracts, something uploaded securely to Azure Blob Storage. Which aid model do we use to extract the key value pairs from that structured content?
You have to use the layout model. The layout model is designed to understand the structure, the tables, the physical layout of the document. That's what lets it accurately pull those key value pairs out.
Excellent. That brings us neatly to knowledge mining and search. And when we talk modern AI, we have to talk about RAG.
Yes, or RAG, Retrieval Augmented Generation, using your own data to make the AI's response factually relevant.
Exactly. So if we're using your data ARG feature in Azure OpenAI, what additional mandatory Azure service do we need to index all that custom data?
It has to be Azure AI Search. It is mandatory. The Azure OpenAI service doesn't index the data itself. It relies completely on Azure AI Search to find the relevant chunks of text to ground the model's response.
And what's the very first step in that indexing pipeline?
It's called document cracking. This is just the initial stage where the system opens the files and extracts all the raw text and images, setting the stage for everything else.
Okay, let's say I'm building a product catalog search, and I need the UI to show a hit count by category, like electronics or apparel. Which search field attribute do I need to set?
You need to assign the faceable attribute. That attribute is specifically what the engine uses to calculate and return those categorized hit counts. It's essential for any kind of filtering UI. And once we've indexed and enriched all this content, maybe translated some fields, extracted key phrases, where does that output go so other applications can use it?
That goes into a knowledge store. You define the knowledge store inside the skill set, and it determines how that enriched data gets projected as tables, files, or objects in Azure Storage, ready for analytics or other apps.
We also need to name the engine for raw content extraction in that enrichment pipeline. What's the specific built-in skill?
That's it. Microsoft.skills.util, document extraction skill. I know, super technical name. But the insight here is you don't have to build custom code for this foundational step. It's a built-in utility. All right, moving into section 3. Generative AI, the core of modern development. For general, high-quality text generation, writing an article, summarizing a report, which Azure OpenAI model is the top recommendation.
It is still GPT-4. For general reasoning and complex, contextually accurate text, it outperforms the others. We save models like Vision for image analysis or, DALL-E for visual content.
And if we pivot to generating visual content from a text description?
That is DALL-E. And if you're implementing the DALL-E 3 API, you have to remember the 3 mandatory HTTP header properties for every single request.
Sure.
The API version, the name of your Azure OpenAI service resource, and the DALL-E 3 model deployment name. Miss any of those, and it fails. Let's talk prompt engineering for a second. The sources highlight 3 core strategies that Microsoft recommends.
They are: be descriptive, which often means using analogies to clarify your intent. Be specific, leaving as little room for interpretation as possible. And order matters, recognizing that the sequence of information really affects the output.
And what's fascinating is what's excluded. The sources explicitly say be simple is not a recommended best practice.
All right, you'd think it would be. But for these large models, simplicity often just leads to ambiguity. Being descriptive and specific ensures alignment, even if the prompt gets a little longer. You're trading brevity for precision.
That's a fantastic insight. Now, corporate compliance. If my organization requires every code snippet to follow strict coding standards, how do I enforce that with a prompt?
The model needs examples. You have to provide standard compliant examples right there in the prompt itself. The model will learn the pattern and style from those examples. Security is always critical. We're seeing more user prompt injection attacks, UPIA, or jailbreaking. Which Azure AI service do we need to detect and prevent those?
That service is Azure AI Content Safety. It's designed specifically to guard against UPIA by recognizing the patterns of attacks.
What kind of patterns?
It looks for 4 types: attempts to change system rules, embedding fake conversation mockups, role-playing scenarios designed to confuse the model, and encoding attacks. It's your frontline defense.
Shifting back to RAG for a moment, If a listener is using their company data, but the grounding is poor, the responses are not accurate, how do they turn up the dial on relevance?
You have to configure the strictness parameter. Raising this value sets a higher relevance threshold. You're basically telling the search system, only bring me documents that are a near perfect match.
And for maximizing precision in the underlying search index itself, what should we enable over basic keyword search?
Oh, you absolutely need to enable semantic search. Keyword search is okay, but semantic search understands the meaning and context of the query, not just word overlap. It leads to dramatically higher precision for RAG.
Final detail on RAG-supported file types for grounding data. What should we use and what should we avoid? You can use TXT, MD, HTML, PDF, Word, and PowerPoint files. But the sources are clear. Do not try to use XML or ZIP files. They are not currently supported. Okay, we've optimized, we've secured, we've grounded our models. Now, Section 4, agentic systems and orchestration. Agents need to perform actions, right, like setting notifications. What do we do in the Azure AI Foundry agent service to enable that?
You must add custom functions. These functions define the external tools the agent can call. It's what gives the AI the ability to perform programmatic actions in the real world.
And when we're building complex multi-agent workflows where different AIs cooperate, which framework is the most suitable for that kind of orchestration?
That would be the semantic kernel framework. It is designed specifically for orchestrating generative AI components and complex flows. It's important to distinguish it from, say, the Azure Bot framework, which is great for conversations, but lacks semantic kernel's deep orchestration capabilities.
What if an agent needs to access real-time data from external APIs? What are the 3 primary actions required?
First, you define tools for API access. That goes back to those custom functions. Second, you have to configure the Bing search tool for just general real-time web queries. And third, you need to deploy the agent using the Azure SDK to make it operational.
What about multilingual support in these orchestration projects? Can I build one workflow that handles, say, English and Spanish?
Unfortunately, no. Orchestration workflow projects do not support the multilingual option. The recommended approach is to just create separate workflow projects for each language. And when you're building a workflow based on Azure AI language, what's the crucial rule for connecting to other services like language understanding?
The rule is all about governance. They can connect only if those other services are owned by or live in the exact same Azure AI language service resource as the workflow. It keeps the security boundaries consistent. This brings us to a really fundamental limitation of the Azure AI language question answering service. What scenario is it perfect for, and where should developers avoid it?
It is excellent for scenarios with static information data in a fixed knowledge base, and when the goal is to provide the same consistent answer every time.
Okay.
It is not suitable for dynamic information or for generating a unique, novel answer for every request. That is a key architectural constraint to remember.
Fantastic summary. Let's finish with some deep cuts on vision, language, and translator services. If we're using Azure AI Vision to detect the mere presence of people in a video feed, say, for crowd counting, which feature do we use?
You have to use the spatial analysis feature. It's built specifically for detecting people, tracking their movement, and analyzing those spatial relationships in video. And we often deal with tricky images. To improve face detection accuracy for blurry, small, or side view faces, which specific detection model do we need to set?
You need to set the detection model to detection 03. Yeah, that model is specifically optimized to handle those challenging edge cases. It's much more robust for identifying and locating animals in images, not just saying it's a cat, but drawing a box around the cat. What do we train in Azure Custom Vision?
You have to train an object detection model. Classification just tags the whole image. Object detection gives you the location, the coordinates, which is essential. Once we've trained that model and the metrics look good, what's the immediate next step to get it into production?
You have to publish the model and retrieve its prediction URL and key. Publishing is what turns it into an API endpoint that your application can actually call. And when we're assessing its performance, what are the 2 key metrics we need to evaluate?
Precision and recall. Precision tells you how correct your positive IDs are, and recall tells you how many of the actual targets you found. You need both.
To efficiently improve labeling on a huge training set, there are 3 actions to focus our effort. What are they?
Okay, first, use the Smart Labeler to get initial automated tag suggestions. Second, Have your human experts review and confirm those suggestions. And third, most efficiently, you prioritize reviewing tags with high prediction uncertainty. That's where a human makes the biggest difference. And if you need to guarantee an image has only a single category, one species of animal, for example, which classification type is required?
You have to lock it down using multi-class classification.
Mm.
Multi-label is too primitive. It allows 0 or more tags, which defeats the whole purpose. Okay, jumping to language. To identify the core concepts in a big document using Azure AI language, which endpoint do we use?
You'd use the key phrase extraction endpoint.
Yeah, and for PII detection, if we specifically want to flag staff member names, which category do we use?
You should use the person category for that. Here's a fascinating niche detail from the video indexer. When you upload custom language models as text files, what common special character has to be removed where the sentences will just be discarded?
The character, the ampersand. That is exactly the kind of non-obvious detail that can silently wreck your model if you don't know about it. Finally, translation accuracy. Let's talk BLEU's score. Scale is 0 to 100. What score range indicates a high-quality translation?
A high-quality translation is generally a score between 40 and 59, maybe 60. While 100 is perfect, a score in the 40s to 50s indicates a really robust overlap between the machine and a human translation. And what's a critical rule of thumb when getting training documents for a custom translation model?
The sources are clear. Be liberal. The principle is that any in-domain human translation, even if it's imperfect, is significantly better for training than just using generic machine translation.
And lastly, for transcribing truly large audio files with Azure AI speech batch transcription, what's the recommended storage?
Azure Storage. It's a recommended and, by default, the only supported storage provider for the batch transcription service.
Wow, we just completed a massive deep dive. We went from the platform foundation in Foundry all the way through to these granular constraints on video indexing. We talked about why the layout model is key for documents, the absolute requirement of Azure AI search for ARIG, and the strategic importance of configuring strictness for accuracy.
Yeah, and we covered specific technical constraints like using detection 003 for blurry faces, but I think the major architectural lesson is around the agent systems.
Yeah.
We learned that the semantic kernel framework gives us incredible power for orchestration.
Right.
But we also confirmed that the core Azure AI language question answering service is, at its heart, limited to static fixed data. And that dynamic, that creates a huge challenge, doesn't it? Knowing that agents can run this complex code and orchestrate systems, but the core knowledge bases they access are fixed. What new agentic workflows could you design to truly bridge that gap? The gap between fixed corporate knowledge and the need to access real-time dynamic information. That's the question that I think will drive the next wave of development.
Keep exploring those sources.
We hope this deep dive gave you the blueprint you needed to start building. Until next time.